Okay, so first of all, what we need to do for this one is we need to get the chemical formulas for potassium dichromate and for iron 3 sulfate. And dichromate, Cr2O7, is a 2 minus charge, and K is a +1 charge, or 1 plus. And so I'm going to need two of those to neutralize the two minuses, and so that's the formula for potassium dichromate. I do the same thing with iron. Fe3 with the 3 in the brackets means 3 plus, and SO4 is a 2 minus ion. So the lowest common multiple of 3 and 2 is 6, so I'm going to need 2 of those and 3 of those. Now we know that what the products are going to be. The products are going to be this negative ion combining with this positive ion, and so we're going to have Fe combining with Cr2O7, and again that's 2 minus and that's 3 plus, and so we're going to need a 2 and a 3 for that one. And the other one is going to be K combining with SO4. So we've got K goes with SO4, and that's a 2 minus and that's a 1 plus. So I'm just going to need two of those to balance the negative charge there. So that's my reactants and products. I'm just going to tidy this up a little. It's better. Now I don't have any states on the other side of the arrow here. So I need to use the solubility table or rules that I know. One of the main things that we know is that potassium is always soluble. So this is not going to be a solid here. Now, if it's a precipitation reaction, that only leaves this one. And so we can fairly safely assume that the iron dichromate is going to be the solid. Now, once I've got it like that, what I want to do is I want to balance the equation before I move on to breaking it up into the separate ions. So what we're going to do is we're going to start off from the left and work our way through left to right, and as soon as we make a change, we're going to start again. So how am I going to do that? Well, I start off here. I've got two Ks over here. I've got two Ks over here. So K is okay at the moment. Now, moving on, I've got Cr2O7, I've got one of them over here, and here I've got three of them. So what I need to do is I need to go back and I need to put a 3 in front of this. Now, because I've made a change, what I'm going to have to do is start again. So we'll just rub all that out, rub all that out, rub that out. Nothing's okay now because I've made a change. So now I start again. So I've got 3 times, oops, just rubbed out half of my 3. Well, a portion of my 3. It's very poor maths to call that a half. I've got 3 times 2 is 6 Ks on this side, and I've got 2 Ks on this side, so I need to multiply that by 3. So I can go back and start again, but since I'm at the very start here, I don't need to. Now for the next one, I've got 3 Cr2O7s. I've got 3 of those, and now I've got 3 of those on that side, so that's fine. Moving on, Fe2, Fe2. Well, Fe's okay. So that one, so I've done the Ks, I've done the Cr2s, I've done the Fe's. Now, technically, the other one has to be okay, but let's check it. SO4, I've got 3 of those, and here I've got 3 lots of SO4, so I now have the balanced chemical equation. Fantastic. So once I've done that, what I'm going to do then is I'm going to break up everything that's aqueous into separate ions, and then start removing the things that are the same on both sides. So let's see how that works. Now this one here is aqueous, this first one here. So this breaks up into 6K plus aqueous, because there's a total of 6 Ks, plus 3 Cr2O7, 2 minus, which is also aqueous. I've got to end up with the same number of parts here, plus 2Fe3 plus, aqueous, plus 3 SO4 2 minus, aqueous. And that turns into, this one's solid, so it stays together, Fe2 Cr2O7 3, solid. Yeah, okay. Plus 6K plus aqueous plus 3SO42 minus aqueous. Now you can see already how this is going to pan out. So once I've got this here, this is that equation above broken up into spectator ions. What I do now is I go from left to right. I'm going to work through each of the reactants and see if they're the same, identically the same on the other side of the arrow or not. So the first one here, 6K plus aqueous. I go to the other side of the arrow, 6K plus aqueous. It's exactly the same as it is on the reactant side, so I can cross it off both sides. It's not doing anything, it's not changing, so it's a spectator. Here, the next one, the dichromate ion, there's 3 of those. They've got a negative charge and they're in aqueous state. Over here, the dichromate ion is bound up with iron and it's in a solid state. So that one, I'm going to keep that one. I'm going to keep that. All right, let's move on to the next one. Now, the next one is Fe3+. I've got 2 Fe3 pluses in aqueous state over here. I don't have any Fe3 pluses in aqueous state over here. The iron is combined with the dichromate, just like the dichromate was. It's changed from aqueous to solid, so this one also we are going to be keeping. So we're going to keep this one. Oops, keep that. And then finally, we have a look at the sulfate. I've got 3 SO42 minuses in aqueous state here. Over here, I've got 3 SO42 minuses in aqueous state. And because they're exactly the same quantity, same charge, same state, they're spectators and we can get rid of them. And that gives us the overall equation, which is 3 Cr2O72 minus aqueous. Well, the overall equation with the spectators removed. Plus 2 Fe3 plus aqueous goes to Fe2 Cr2O73 solid. And that's it.